So, yeah, hello, we are the team iBots and we'd like to welcome you to our technical demonstration today. Our show this year has a lot of cool and new technologies, and I'd like to start with our own developed indoor GPS system. So for this, basically, we need 3 anchor points. As you can see, they are positioned in the corners of the stage, and 1 tag, which sits here on our main robot. Then we measure 3 distances, and out of the 3 distances, we can spread up these 2 triangles, and with the aids of the triangles, we can then find the coordinates of the robot where it's located on the stage. Yeah, the method behind this distance measurement is called time of flight. So the signal travels with the speed of light, and we have the timestamps when the signal starts traveling and comes back. So with time and speed given, we can then easily calculate the distance. Yeah, as chips we use the DWM1000 from Decawave, and it has the same communication protocol as Zigbee does. So now we would like to give you a quick demo of how it works. So this is Alice here with the tag, and our coordinate we want to drive now sits here, so 3 meters here, 1 meter up. At first, we also use a compass sensor, and it has to calibrate real quick. Also, the robot gets started with ultrasonic. Okay, so now it should drive to the point 3 meters and 1 meter. Okay. And we calculate the new coordinate values very quick. Yeah, and it stops around 3 meters and 1 meter up. So that's our first technology.
So the next part of our performance is in the end, in the second half. There is another system of orientation on the stage to help Alice come out of the Wonderland in the end. Me, the header, leads her with this infrared light on this board. And Alice has infrared sensors on her front, you can see them here. And by getting out where the infrared light comes from, you can see this here. She either turns to the right or to the left, or just drives straight forward. I am going to show you this now. Okay, so if the light is in front of her, she drives forward, and now she turns to the right or to the left. Okay. So now let's come to the mechanics of Alice. Alice was completely self-developed by us in a CAD program. So we planned her with 3 motors. You can see them here. And the 3 wheels, they're called Meccano wheels. The good thing at them is that we can drive to the side without moving the axis of the wheels. Then we use a chain connection from the motor to the axis, that there is not the pressure of the whole robot, that's about 20 kilograms, on the motor axis, but on the steering rollers. The circuit boards you can see here and here are also self-developed by us. We did this to bring our own needs with the motor drivers, our own circuits on the board without buying any parts.
Okay, so another robot we have built to tell our story is the rabbit. And as you can see, he has a pixie camera in order to perform tasks such as following Alice. And we use it because it's so flexible and fast by outputting what it detects 50 times per second. And the pixie camera processes the images from the image sensor but sends only the useful information to our microcontroller, and the information is available through the interface SPI. And now we want to show you. And so first I want to show you a diagram. So here you can see the x-axis, and the robot always angles itself to the middle of the color tag, and when it's in the right section, the robot turns right. When it's in the left section, is turned left, and we have a threshold value of 50.
To get into the Wonderland, Alice needs to go through the gate, and the gate opens when the real Alice, trigger the light sensor on Alice, and then the gate opens with a motor which pulls it up. Then the motor is holding it until Alice gets through the gate, and then Alice sends back a Bluetooth signal to the gate to close it back with the elastic band.
The Cheshire Cat is started via Bluetooth by Alice when she passes her, and then she proceeds to turn around herself with the help of a motor and turns her head with another one. Furthermore, her eyes light up in different ways. And we hope we could give you a short overview, and thank you for your attention.